we are going to see about the communication system, the basic knowledge of modulation. So in modulation is nothing but the data sequence is converted into radio waves in accordance with the modulating signal. Modulating signal is nothing but your input signal or some radio waves. Okay, there are two types of modulation. The first one is analog modulation. The second one is digital modulation. In analog modulation, your input signal is analog signal and also the output signal is also analog signal. But in digital modulation, your input signal is digital sequence, means digital signal, and your output signal will be analog signal. In analog modulation, there are three types of modulation. First one is the basic characteristics of signals, amplitude, frequency and phase. The amplitude of the signal is varied, the amplitude of the carrier signal in accordance with the modulating signal. So, means AM, and the second one is FM, frequency modulation. Frequency modulation is nothing but the frequency of the carrier signal is varied in accordance with the modulating signal. Similarly, in phase modulation, PM, the phase of the carrier signal is varied in accordance with the phase of the modulating signal. These are all the basic modulation techniques. But in digital modulation techniques, there are three types of digital modulation techniques. The first one is ASK, amplitude shift keying. The second one is frequency shift keying, means FSK. The third one is PSK, means phase shift keying. Now we are going to see about the amplitude shift keying. So amplitude shift keying is the basic techniques of digital modulation. In this digital modulation, in ASK, we are another name is called on-off keying techniques. On-off keying techniques is nothing but whenever the input signal is on condition, the output will be is on condition, means the signal will be transmitting in the output side. Whenever your data signal will be 0, means off condition, there is no signal in the output side. So in ASK techniques is ASK transmitter or ASK generator. How the ASK signal will be generated? Okay. Now your input signal means product modulator. We are using product modulator. There are two signals are in product modulator. The first one is input signal, means ASK means your binary signal is your input, binary data sequence. So we are using B of t, and here we using the carrier signal. And your output will be generated ASK signal. Product modulator is nothing but multiplied the two input signals. So your input signal is B of t and the high frequency carrier signal. So the output of the product modulator is ASK signal. So in this ASK signal, we can represent ASK of t is equal to Vc cos omega Ct into your input signal binary sequence B of t. In this ASK, we can represent, in case your binary signal B of t is 0, what happened the ASK value? VASK of t is equal to 0. In case your binary signal will be 1, B of t is equal to 1, your VASK of t is equal to 1. Means the carrier signal will be very high value. This generator will be generate your input binary signal and it will be generate the analog signal of ASK. Similarly, whenever your input signal, for example, your input signal is 0, 1, 1 and 0, 0. Whenever your input signal will be 0, there is no signal in the output region. Whenever your input signal is 1, the signal will be transmitting in the output side. Yes, this is the concept of ASK. Now we are going to see about ASK detector as nothing but demodulation. Now we are going to see about ASK detector. So ASK detector. In this ASK detector, your input signal is ASK signal and your output signal will be binary signal. So here we using the three main important blocks. So first one is correlator, the second one is decision device. So there is a threshold value, then finally we can get the output signal. Okay, first your input signal is ASK signal. And this ASK signal is giving to the correlator. Correlator is consist of modulator and integrator. So integrator. So okay, here this block diagram represents your input signal is giving to the correlator. Correlator consists of the product modulator and integrator. Okay, now in this product modulator we will giving the three input signal. First signal is ASK signal and second one is carrier signal. Carrier signal is high frequency signal. The output of this modulator is applied to the integrator. Both the values are correlator. The output of the correlator or integrator represents some values. We can assume the value is nothing but Y. The Y is depends the output binary values. How it is possible? There are three ways. First, your Y value is greater than 0. Greater than 0 is nothing but all positive values. So it will be generate the binary 1. Binary 1 is nothing but high input signal. Okay. And if suppose your Y value is less than 0, means negative value. So it represents the binary 0 output, means 0 output. If suppose your Y value is 0 or 1, the decision device will consider the signal will be very high. So it will be considered the binary value 1. So whenever the output of Y, if 0 or means positive or negative, in case negative signal means there is no signal in the output side. In case positive means the binary value will be 1. So the decision device decide whether this binary sequence is transmitted or not. If B of t value is transmitting means 1 means the value will be 1, 0 means there is no signal. Again 1 means it will be transmitting in the output side. So every time the carrier signal Vc of t into B of t, that is your ASK signal. Okay. This ASK signal is the basic techniques of modulation scheme. It's very useful for transmitting the signal. Thank you. Okay. Now we will see about the power spectral density of ASK. Power spectral density of power spectral density of ASK. So here the input signal is ASK signal, means amplitude shift keying signal. It's applied to the band pass filter. The band pass filter output is mainly the high frequency signal, and it will be applied to the input of envelope detector. Envelope detector splitted into unmodulated carrier signal, and it will be applied to the input of decision device. It is already similar to your detector of ASK. So this threshold value is depends on the previous value. Y is equal to 0 means there is no binary signal, and y is equal to 1 means the binary signal will be transmitted in the output side. This here we can represent the binary signal is SK of F, means frequency, which is equal to the bit time TB divided by 4 sinc square of sinc theta divided by sin theta divided by theta, which is equal to sinc square of F into TB plus 1 by 4 into del of F, means impulse response of the signal. Now we are going about the waveform of your spectral density of ASK of F. This ASK is represent the high frequency signal, means this value is always F is F plus TB, means your bit time rate, and this also this value is represented in the positive region, and in case your F value minus TB, it will be represented in the negative region. So negative region is always represented in the binary zeros, and positive value is represented in the positive region. It's always represented in binary 1 value. These are all the explanation of ASK. Here we can represent the signal in binary 1 or 0, and your input signal is binary signal and our output signal is ASK signal. Thank you.